This experiment is on surface tension. We will be trying to float a paperclip on water. You'll need a glass bowl, water, a paperclip, preferably a small one. Tweezers are optional but recommended, and a bowl of dish soap. Make sure to do this experiment with a parent or guardian around you. Pour the water into the bowl. Fill it close to the rim. This will help with the experiment. Taking your tweezers, pick up the paperclip and try and float it on top of the water. As you can see, floating the paperclip is difficult. While you're trying to float the paperclip, let's talk about what makes things float. Density is the key word to understanding how things float. Objects with higher density have more stuff in a smaller amount of space. Objects with high density sink. Objects with lower density have less stuff in the same amount of space, and these objects float. So in this case, you probably think paperclips have higher density than water. You're correct. Paperclips should sink in the water. However, there is a way to make them float. If you steady your hand as you lower the paperclip into the water, keep the paperclip flat and slowly enter it into the water and it should float.
You might wonder, why does this happen? Everything around you is made up of tiny particles called atoms. Atoms can sometimes bond with each other to form molecules. Water is made up of molecules. These molecules have the atoms hydrogen and oxygen. There are 2 hydrogens for every oxygen, and that makes up 1 water molecule. The water molecules are attracted to each other. This attraction forms a tension on the surface of things like this water bottle, like this bowl. This tension of the attraction between the water molecules forms a skin on the top of these things around us.
Surface tension is all around us. It's how these bugs that you see on ponds and lakes are able to float.
This skin is what makes it so that the paperclip can float.
Take the paperclip out, and now we're going to add dish soap to the water. We're going to try and float the paperclip again, but now with the dish soap in the water. What do you think is going to happen? Pause this video and talk to the people around you about what you think will happen. Let's observe what happens. Let's look at this from another angle to give you a better view of what actually happens to the paperclip when dish soap is added to the water. As you're watching me try to float the paperclip, make sure you're trying to float it yourself at home. As you can see, I'm setting my hand and lowering it the way that was successful before when it was just water. But now that the dish soap is added, the paperclip will not float on top of the water. Why do you think this is?
When we added the dish soap to the water, the dish soap is made up of different molecules than H2O. These molecules get in between the H2O molecules that make up water. And these new molecules make it so that the H2O molecules don't have the same attraction with each other. The breaking of this attraction makes it so that the skin on the surface of the bowl and the water bottle and the bowl that you saw in the video, the skin breaks and the paperclip can't float on it.
Thank you for joining me during this experiment. I hope you enjoyed it, and I hope you also learned a lot about how water molecules are attracted to each other to form surface tension.